This is what 22 years does to a man. Not sure which is better. Hey guys, welcome back. Finally finished the three-phase to single-phase conversion of my lathe using the broken VFD I found at the scrapyard. You can see it in the box there. Along with being able to use single-phase instead of three-phase, I added a few other features such as speed control, an e-stop, and the ability to use the original handle of the lathe in order to switch it in forward and reverse. I'll quickly go through what I have now and how I built it, and then we can look at it on schematic level so you can replicate the setup if you want. Let's jump into it. So the first point I wanted to focus on was safety. I wanted to add an e-stop which can be easily kicked in case your hands get all caught up in this mess. If you're standing here, you can just reach over with your foot and kick the e-stop off. So aside from that, since this is a wood and metal workshop, I would often cover the lathe when I'm not using it with this cloth here. And that leaves it in a little bit of a precarious state because if somebody were to walk by and hit the switch with the cloth on it, it would get all tangled up in this mess and it's not so cool at all. So what this setup allows me to do is to cut power to the entire enclosure, and therefore no matter which position this switch is in, nothing will turn on. So if there's no power to the cabinet like that, and somebody does walk by and flip this switch into forward or reverse, so right now it's in forward. If I come over here and apply power to the cabinet, nothing will happen. And the reason for that is the VFD is programmed to be in edge control rather than state control. So even if there's a forward signal from the handle here, there was no edge transition and therefore it's not going to start. So in order to get it to start, you have to switch this back to 0 and then switch it once more. Alright, so it can get a little bit annoying switching belts on these old lathes. I guess anybody that has one knows this game. If you need to change the speed of the chuck a little bit, you have to always fight with the belt, which is a little bit annoying. So I wanted to add a speed control, which I've done here with this little box. I made a couple markings there where 0, nominal, and 11 is. So nominal being 50 Hertz, the motor in this lathe is 50 Hertz. And I've programmed the VFD to allow 0 to 100 Hertz operation and torque boost under 50 Hertz. So that means I can go twice as fast as the motor is designed for, and below 50 Hertz, so slower than its normal rated speed, the VFD will boost the current up to 100% of the rated current. So this motor is in 220 configuration, so in a delta 220 configuration, the nominal phase currents should be 3.5 amps, and that means that the VFD will drive it up to 7 amps phase in low speeds, so you don't lose torque at low speed. All right, so the motor in this lathe is a 1.1 horsepower, 3-phase, 50 Hertz motor. And it can be wired for either 380 volt 3-phase or 220 volt 3-phase. Typically your 380 volt will be wired in a Y configuration, Y that's WYE, and 220 volts will be a delta configuration. Since I'm using a single phase VFD, you can't get over the line voltage out of it. So we have a line voltage of 220 here, and that means the maximum 3-phase output voltage of the VFD will be 220 per phase. And that means if you leave your motor wired in 3-phase 380 configuration in Y, you'll be providing the impedance of 2 phases to the VFD output. And because the VFD is only providing 220 instead of 380, you're going to be providing way too much impedance to the VFD, and therefore you're going to lose torque on your motor. On every motor that I've seen, there's going to be a little cap or a little box on it like this right here. And inside there should be 6 terminals pulling these 6 phase wires out, so the 3 coils. The wire on either end of the coil will be coming out here, and there will be little plates that you can change the configuration. Usually there's a diagram inside as well. All right, let me just show you what I've got going on here. So I replaced all the wiring in the entire lathe. So I've got this new electrical box here. Here I've got connections. There's this white cable that goes to the switch at the end of the bed down there. There's another orange cable back there that you probably can't see that also goes to the switch. Then there's this cable which goes to the VFD, which has the 3 phases, and the signals from these 2 cables from the switch. Because I didn't want to redo all the wiring to the switch, I just cut off the original 3-phase cables and wired them in here. Then there's one more cable down here which goes to the motor. So that's all new. Then in the box itself, you have a main power switch. This is one of these lockout style switches, or you can put a little lock here. Right. By the way, I found all of this stuff at the scrapyard, so the cost of this is like 0. I've got 2 indicators here. I need to make labels for them still, but basically this is a fault, a no fault indicator from the VFD. So as long as this is on, there's no fault. If this is off, there's a fault, or the VFD doesn't have power. This one here is a general power to the box itself. And I've just got that wired up to the 24-volt DC supply. And it's mostly for me to remember to switch off the power here before I leave the shop. And in the box itself, we've got the VFD. Then there's this 24-volt DC power supply. So there I've got a little voltage regulator that's powering the fan, which is down here with an entirely overkill grill that I made for it. Then we have a contactor here. So this is making the 220 connection to the VFD via the e-stop. And there in the corner, there is a 220 to 24 volts, or 240 to 24 volt. I always mix it up what we have here for voltage. Transformer, which is powering the coil of the contactor. I found my old childhood sketchbook here. I think these empty pages represent the forgotten dreams that I maybe once had. Check it out. I drew that when I was 9. A whole bunch more in here. I've illustrated the basic components that are in the cabinet. So here we have the lockout switch. That's this big main power switch. Then the e-stop. This is the, I forgot to label it. This is the transformer. So here we've got the contactor, the VFD itself. This, actually, you don't see a little piece of it. There's actually 3. This is the switch inside the handle of the lathe, the 2 lights, and the 24-volt supply. I'm missing the fan also. So the first thing, we can start with earth. The first thing I did, this gets tied to the case itself, and all of the earths inside get tied together. Never switch earth, so this is always tied together like this. We switch the line and the neutral through the lockout switch. And the reason that the neutral is switched, so normally you shouldn't have to do that, but I found with this particular VFD, it gets some kind of strange error if it loses line but not neutral. So it actually throws an error, and I've found out that switching the line together with the neutral solved that. So after the lockout switch, we have the switched line and neutral, and those will get connected to the 24-volt DC supply and the top side of the contactor, like that. Then the bottom side, so the switched side of the contactor, will get connected to the VFD. Like this. Likewise, the switched voltages here will get connected to the transformer. This one, yeah, okay, it's gonna start getting a little bit confusing. Okay. So those are the main 220 connections that we have in the cabinet together with the earth. Then let's start with the e-stop circuit, and I'll draw those connections in, let's say, this green color to keep them a little bit separated. So we have one loop that's independent of all this other stuff, just for the e-stop. So this transformer steps down the 240 to 24 volts AC. The 24 volts AC, we can actually label it 24 for AC, is needed to drive the coil of the contactor. So the way I've got that wired up, the one output goes here to the e-stop goes to the coil then comes back to the transformer. So as long as the e-stop is closed, which is its normal position, the currents can flow here and the contactor will be closed. And as soon as you hit the e-stop, the circuit is open, the coil has no more energy, and the contactor is opened, and thereby cutting power from the VFD. I've got the 24 volt DC power supply, which has an output that I'm using to drive the two indication lights, as well as the fan. So the fan is a 12 volt fan, doesn't run on 24. So I've got a little 7812 here. Just draw these in like this, converts the 24 volt to 12 volt. Additionally, I've got the power indication just powered by the 24 volt supply. So when this has power, the power is on. That's mostly just so I remember to switch off the power before I leave the shop. So that's just connected like that. And then there's this no fault indication light, and this is connected also to the output of the 24 volt supply here. But then we continue on to the fault relay, which is located in the VFD itself. So this relay is closed when there's no fault. I think that's programmable, but the way I've got it set up, it's closed when there's no fault. So what ends up happening is, just connect that here. This circuit here, the light will stay on so long as there's no fault. So if the light goes off, either the VFD lost power or there's a fault. Okay, then we've got this portion here. So the VFD puts out a 15 volt supply, and from this 15 volt supply, it is expecting, or it's looking for this 15 volts on either the forward or reverse signal pins. And based on which one has 15 volts, it's either going to switch the motor on in forward or reverse. Now, this is how the three-phase switch looks inside the handle of the lathe. So one phase is not switched. It just stays on. I mean, hold on, this isn't entirely complete. There's also the actual physical breaking of these. So something like that. So when you switch it forward or reverse, what it does is first it switches all the phases together, or not together, but on. And the other thing, forward, it switches in this direction, and reverse, it'll connect them this way. So you basically flip two phases to go forward or reverse in a typical three-phase system. Now, what I need is one input, the 15 volts, and then the output should either go here or here. So what I did there was I connected the 15 volt to one of these switched lines here. And the output of that basically goes then either to the forward signal or to the reverse signal, depending which way you have the switch. Alrighty, well, that was basically the video. If you liked it, found it useful, leave me a like, a comment. If you have any questions, also comment below. I'll try to answer them as best I can. And I hope this was useful for you, and see you in the next one. Ciao.